Alright, so let's solve this integral using trigonometric substitution. First of all, what's the substitution? Look at the square root part. So from the table, I know it has something to do with sign. A square here is, A square is 36, so square root of 36 is 6, so A is 6, right? So decide that very carefully. X is equal to 6 sine theta is the correct substitute. Now don't forget you have to replace dx too. So differentiate x, dx over d theta. Derivative of sine theta is cosine theta, so it's 6 cosine theta. So dx is 6 cosine theta d theta. Perfect. Let's substitute now. So x square is going to be 6 square sine square theta, so it will be 36 sine square theta. Do that carefully. Don't just write 6 sine square theta, or don't forget to square any of these terms. Okay, so square every term here. Do the substitution correctly. So here 36 minus x square is again 36 sine square theta. Dx is 6 cosine theta d theta. Alright, don't be in a hurry to simplify things. First, look at the square root. Okay, alright, let these terms be like this. Okay, don't forget to keep writing them, don't drop them. Okay, now inside the square root, now I can factor a common number 36. Okay, so if you have different numbers here and here, that means you are doing something wrong. Okay, so make sure that you have substitute everything correctly. So 1 minus sine square theta. Now 1 minus sine square theta is what? Cosine square theta, right? So that's from the Pythagorean identity. Hope you remember that. So 36, 1 minus sine square theta is cosine square theta. So let me write it again. So sine square theta plus cosine square theta is equal to 1. So if you take the sine square theta term to the other side, so cosine square theta is 1 minus sine square theta. We already know that. Perfect. Now we can finally take the square root because you have no addition, no subtraction, just a multiplication inside the square root. So 36 cosine square theta, 6 cosine theta d theta. If you take the square root of 36 is 6, square root of cosine theta is cosine theta. Okay. Alright. Now here, I know I could have multiplied 36 and 6 and written here. Okay, but I didn't do that because now what you need to do is you need to simplify your integral as much as possible. See, they cancel out. Okay, so that is why I just delay the simplification until I get rid of the square root. Most of the time in the trigonometric substitution problems, after you simplify the square root, you will be able to cancel many terms. Okay, at least couple of terms like here. All right, okay, so let's see what's going on. So now it's just 36 cosine square theta is there to integrate. Now let me make sure that I'm doing everything right and I have not missed something. Yes, of course I did a mistake. How come I got cosine square theta here? Because it should be sine square theta. I did a copying error. Yes, I'm glad that I checked that out. Otherwise, I have to make this video again. Okay, perfect. It didn't affect our simplifications though. So see, it's very easy to do mistakes in these type of problems. Okay, there's lots going on. Let's make sure you also look at this problem very carefully. Okay, so this seems to be like correct. Perfect. Now let's integrate. So let's take 36 out and we just need to integrate sine square theta. Sine square theta, we can use the double angle identity. So sine square theta is actually 1 minus cosine 2 theta over 2. So let's replace this here. So 1 minus cosine 2 theta over 2 d theta. Take that 2 outside. Well, that means half. 36 over 2, 1 minus cosine 2 theta d theta. 36 over 2 is 18. If you integrate 1, you get theta. If you integrate cosine, you get sine 2 theta over 2, right? Plus c. Now next thing you want to do is get rid of that 2 theta, please. Okay, it will help you when you want to convert theta back into x. So theta sine 2 theta is 2 sine theta cosine theta. That's from the double angle identity. Sine 2 theta is sine 2 sine theta cosine theta. This is another version of double angle identity. So divide by 2 plus c, 2 cancel out. So this is 18 theta minus sine theta cosine theta plus c. Alright, so now to replace theta we use the substitute. Remember the substitute is x is equal to 6 sine theta. Okay, so first theta. Well, sine theta here is x over 6, right? Let's take this 6 to the other side. So theta is sine inverse x over 6. So do that carefully, okay? So this is a little bit different from what we did before. We had 1 here and it was all easy in the previous problem. But now be careful. So 18 sine inverse x over 6. Now to replace the other parts, we need the triangle trick, right? So let's make a triangle, theta here. So sine theta is x over 6. So the opposite side is x, hypotenuse is 6. Okay, so now then from the Pythagorean theorem, this is going to be x square minus 36 square root. I did that in my mind. Now here's something you should do. Once you find from the Pythagorean theorem, once you find that missing length of the triangle, go back and check with your original problem. In the integral that we have to solve, my square root part is square root 36 minus x square. But what I have for the missing part is something different. Usually it should be the same. That's a trick. Okay, in most of the cases it should be the same. So I have x square minus 36 square root. That's wrong. So let's see. Okay, it's easy to do mistakes. Let's use the Pythagorean theorem correctly. So x square plus a square, let's call this a, is equal to 36. 6 square is 36. So a square is 36 minus x square. So a is square root 36 minus x square. See, I did that in my mind wrong. So I want you to do the Pythagorean theorem just like I did it here, just to make sure until you get really comfortable with it. Okay, so that's one thing you have to be careful. All right, so now let's replace. Sine theta is actually now opposite over hypotenuse, so x over 6. Cosine theta is actually adjacent over hypotenuse, so here square root 36 minus x square over 6 plus c. So let's see what we get. 18 sine inverse x over 6, here x square root 36 minus x square, 6 times 6 36 plus c. So this is the final solution. Okay, all right, so that's what I have for this video. I will solve more problems in upcoming videos, so see you there.